October 3rd, 2025. NASA's Perseverance rover on Mars captured images of Comet 3I Atlas. The photographs weren't exceptionally clear, but they showed something. An astrophotographer by the name of Simeon Schmaus meticulously combined 20 of those rover images, and there it was, a subtle shimmer of light precisely where the interstellar visitor was expected to be. Speculation is rife, with individuals dissecting the evidence, debating its implications. However, a peculiar aspect arises. On that very same day, a significant portion of NASA's workforce, numbering 15,000 employees, was furloughed. Crucially, the Mars Reconnaissance Orbiter's high-resolution camera, boasting a resolution 3 times superior to Perseverance's capabilities, was perfectly positioned to photograph this once-in-a-lifetime event. The European Space Agency's Mars Express and ExoMars missions were also observing. The question arises, where are those images? The enigma deepens. In August, months prior, remote viewers reported detecting advanced technology aboard this celestial object. They described a device, roughly the size of a thumb drive, deliberately integrated into an ancient comet, emitting pulsating signals. This detection predated any telescopic observations of the object's chemically improbable characteristics. This presentation is divided into 2 segments. The initial half will explore the 3I Atlas phenomenon and any recent developments. The subsequent half will cover general space news from the past week. Timestamps are provided in the description for those wishing to navigate directly to specific sections. Before we delve deeper, if you find this subject matter compelling, please consider liking this video and subscribing to stay informed. In the comments section below, share your geographical location, the current time in your region, and your thoughts on the true nature of this object, whether it is a natural comet or something far more. If you wish to contribute to the growth of our community, please share this content on platforms such as X, Facebook, Reddit, or via your messaging applications. We sincerely appreciate your unwavering support. Chapter 1: The Enigmatic Cylinder in the Martian Sky. Allow me to present something that surfaced on Twitter 48 hours ago, something that fundamentally altered our understanding. A user identified as UFO Mania disseminated an image accompanied by a caption that sent ripples of astonishment through the online astronomical community. The caption declared, "The newest and closest of the 3I Atlas, as it passes, is not a comet. It is perfectly cylindrical." The post included what appeared to be an elongated artifact captured during its Martian flyby, and within hours, it had been shared thousands of times. Now, before you dismiss this as yet another internet fabrication, it is vital to comprehend what distinguishes this event. This was not a blurry photograph obtained from a domestic telescope. The spatial coordinates corresponded precisely, the timing aligned perfectly, and most significantly, the silence emanating from official sources was conspicuous. Because here is the aspect that remains largely unaddressed. On October 3rd, when Comet 3I Atlas made its closest approach to Mars, a distance of 29 million kilometers, we should have been inundated with imagery. The high-resolution imaging experiment camera aboard NASA's Mars Reconnaissance Orbiter was ideally positioned. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter had their instruments precisely aimed at the object's predicted location. Multiple spacecraft, observing from diverse angles, were poised to achieve the highest resolution ever attained of an interstellar object. Yet, we received nothing. Or rather, we received silence. However, into this void of information stepped voices that could no longer be ignored. An account known as 3I Atlas Anomaly began publishing a technical analysis that far surpassed the usual discourse associated with conspiracy theories. It presented 10 specific points, each referencing documented observations. These included a carbon dioxide-rich coma detected by the James Webb Space Telescope, water and hydroxyl emissions identified by the Swift Telescope, and polarimetric anomalies indicating a negative 2.77% polarization at a phase angle of 7 degrees, a combination entirely unprecedented among known asteroids and comets. Reflect on that for a moment. This was not vague conjecture. These were citations of actual instruments, empirical measurements, and published scientific papers. Then, the cosmologists emerged. A Twitter user named Moneypenny, who identifies herself as an expert in plasma phenomena and a former BBC journalist, posted a statement that prompted even skeptics to pause. She asserted that a prominent cosmologist, Stephen Burns, believes the object is sentient, enveloped in dusty plasma, and exhibiting a form of consciousness that is actively communicating with us and with other celestial bodies. Consciousness actively communicating. You might perceive this as venturing into fringe territory, and perhaps it is. However, this is where the narrative becomes truly intriguing. This information was not relegated to obscure corners of the internet. It was publicly accessible, presented with Moneypenny's credentials, and her background in investigative journalism prominently displayed. She appended one additional detail that sent a shiver down the spine of anyone paying close attention. We can no longer observe it as it is too close to the sun. Therefore, it will be December before we can view it again. December. 3 months of waiting. 3 months during which the object would be concealed behind the sun, entirely invisible to every telescope on Earth. And during this 3-month period, any alteration in its trajectory would remain undetected until its reappearance. Then there was Jon Stewart, not the comedian, but a UFO investigator and journalist, who published a statement that read like an admonition from a bygone era. He wrote, "My source has gone dark. NASA is shutting down, and even Congress is in recess. If 3I Atlas activates, ancient texts warn, the sky will burn with knowing light, and the world will forget its reflection." They labeled it prophecy. The agencies termed it protocol. I perceive it as imminent. Hashtags such as our ancient texts, our Vatican files, and the Harbinger were trending alongside detailed astronomical discussions. What are we to make of this? How does one discern the meaningful signal from the pervasive noise, especially when the noise itself might be the signal? Because here lies the unsettling truth. In the preceding 48 hours, as these posts gained viral traction, not a single official image from the Martian flyby has been released. This silence extends from NASA to the ESA and even to China's Tianwen-1 mission and the UAE's Hope orbiter, all of which were positioned to observe. The sole visual evidence available originates from Simeon Schmaus, the astrophotographer who meticulously compiled 20 images from the Perseverance rover's Mastcam-Z camera, revealing what he characterized as a faint luminous smudge within the Corona Borealis constellation, near the expected location of the comet. A faint smudge. That is the extent of what we have received from humanity's most intimate encounter with an interstellar visitor, captured by spacecraft capable of resolving objects smaller than a car on the Martian surface. We received a faint smudge. Unless, of course, they observed something entirely different and deliberately withheld that information. The 3I Atlas anomaly account continued to post updates that grew increasingly specific. They noted unexpected brightening, stating, The object is brightening faster than predicted by models, suggesting more volatile or efficient outgassing mechanisms than anticipated for its distance. Furthermore, they highlighted the challenge of observing during solar conjunction. As the object slips behind the sun, ground-based observations cease. ESA is repurposing Mars orbiters to monitor it near the October 3rd Mars flyby at approximately 30 million kilometers. Every update was technically precise. Every detail could be corroborated with published scientific observations. And yet, the conclusion they were inexorably building towards was undeniable. This object was not behaving like a comet. Then came the detail that defied easy explanation: its shape. Multiple independent amateur astronomers reported the same observation. Upon processing their images, enhancing contrast, and removing background stars, what remained was not the diffuse, irregular mass expected from a comet with an active coma. Instead, it appeared elongated, smooth, almost geometric, perfectly cylindrical, precisely as UFO mania had suggested. Skeptics might argue that elongation can be an artifact of motion, image processing, or the way light scatters through a coma. And they would be correct. It can be. But it can also be indicative of reality. We know this because Oumuamua, the first observed interstellar visitor, also exhibited elongation. Some described it as pancake-shaped, others as cigar-shaped, but unequivocally not round. It was certainly not what was anticipated. Therefore, when 3i Atlas displays similar characteristics, when numerous independent observers report the same geometric quality, and when official channels maintain their silence, what are we to conclude? NASA's carefully worded official statements indicate that 3i Atlas poses no threat to Earth. Its trajectory ensures it will remain safely hundreds of millions of kilometers away from our planet. It is projected to reach its closest point to the Sun on October 30th, subsequently continuing its journey out of the solar system, never to return. All of these assertions are factually correct. However, they sidestep the fundamental question that everyone is contemplating. What precisely is it? And why, on the very day we were supposed to obtain our most detailed observation, were 15,000 NASA employees sent home? Chapter 2. The Revelation of the Remote Viewers. What I am about to convey transpired in August of 2025, 2 months before the Martian flyby, preceding the government shutdown, and prior to any of the viral online posts that captured public attention. This occurred under circumstances that render it impossible to dismiss as wishful thinking or confirmation bias. Her name is Bertie Jorsky, and for those familiar with remote viewing, her name is widely recognized. She is a former vice president of the Farsight Institute, possessing nearly 30 years of professional remote viewing experience, and holds a master's degree in digital forensics. This background is hardly indicative of someone seeking internet notoriety through outlandish claims. In August, a friend provided her with a set of coordinates, devoid of any context, photographs, or news articles. This is the standard procedure for legitimate remote viewing. The target remains entirely unknown to the viewer until the session is concluded. Bertie commenced her protocol and began to describe her perceptions. Her initial observation was of movement through space, an entity in transit, something ancient, profoundly ancient. She characterized it as a natural object, composed of ice and rock, precisely as one would expect if asked to remotely view a comet. For a period, this was the entirety of her description. However, she then detected something unusual. She later recounted in a podcast discussing her findings. There was something that was not entirely natural. She described it as akin to discovering a fingerprint on an object that should be pristine, a signature where only randomness should exist. Continuing deeper into the session, she perceived it. Something small, approximately the size of a thumb drive. She reported that it had been deliberately placed within the object, not on its surface, but internally. She stated, "Someone had bored into this icy rock deliberately and placed something encoded with all kinds of information. It's kind of like an archive, a message in a bottle. But it's not just a message. It's technology of some sort." Pause and consider what she is describing. Not alien beings, not a colossal spacecraft, but a thumb drive-sized piece of technology, incredibly ancient, concealed within a comet that has been traversing the galaxy for billions of years. She elaborated further. This thing is so old, and even though the object itself is like billions of years old, the thing that was placed inside of it is also very, very old. Did some species there on the other side of the galaxy send up a little robot to bore into it and stick their little message in technology, knowing that this thing was going to keep traveling? This is a question that sounds like science fiction, until one recalls that humanity has engaged in precisely such endeavors. The Voyager probes carry golden records, time capsules engineered to endure for billions of years, in the hope that they might one day be discovered. The concept of utilizing natural objects as conduits for messages is not alien to us. We simply haven't considered it in reverse. The friend who furnished Birdie with the coordinates waited until after the session to reveal the subject of her viewing. Comet 3I Atlas, the interstellar object that would not garner mainstream headlines for weeks. Birdie had been remotely viewing something that most of the world was not yet aware of. However, Birdie's work was not complete. She conducted 2 additional sessions, delving deeper in an effort to comprehend her perceptions. In these subsequent sessions, she uncovered a detail that dramatically altered the entire context. She reported, "It is also broadcasting." She described these transmissions as occurring in pulses, broadcasting in the present tense, not as something that occurred billions of years ago, but as an ongoing transmission. When the podcast host mentioned that astronomer Avi Loeb had recently published calculations indicating that 3I Atlas originated from the same sector of the sky as the renowned WOW signal of 1977, Birdie responded without hesitation, "That's super interesting. It is very possible that that is the WOW signal." You may now be wondering about the credibility of remote viewing testimonies. It is not a conventional scientific methodology. It cannot be easily replicated or empirically verified. Skeptics dismiss it outright, while proponents champion its validity. The truth, as is often the case, likely resides in the complex intermediate space. However, Birdie's account warrants consideration for several reasons. She was not alone. Multiple remote viewing groups, operating independently, targeted 3I Atlas in the months following its discovery. While the specific details varied, certain recurring themes emerged consistently: technology, deliberate placement, broadcasting, and the involvement of non-human intelligence. One group reported perceiving humanoid figures associated with the object. Another described what they termed graffiti, markings, or signatures, suggesting someone had signed it. Several viewers conveyed a sensation of the object being camouflaged, intentionally evading detection, as if it preferred not to be fully revealed. One particularly detailed report referenced special access, extraction points, and a timetable. These were not vague, ethereal impressions. They were specific technical details that sounded more akin to an intelligence briefing than a psychic session. Furthermore, there were more disquieting elements. References to crop circles, advanced spherical craft, hybrid warfare, and invisible conflict appeared. The phrase brain scanning technologies surfaced in multiple independent sessions, implying that whatever this object represented possessed the capability to influence minds, instigating mass hysteria or hallucinations. Now, does any of this definitively prove that 3I Atlas is more than just a comet? Assuredly not. Remote viewing, even when conducted with the utmost rigor, remains within the domain of anomalous cognition, not empirical science. These are not precise measurements. They are subjective impressions filtered through human consciousness. However, they exhibit remarkable consistency across numerous independent viewers who had no prior contact with one another, and they align eerily with the physical anomalies that telescopes were beginning to detect. Consider Birdie's description: a small technological device, billions of years old, deliberately placed within a comet. If this were true, what observable phenomena would we anticipate? From a distance, we would expect the object to resemble a comet, exhibiting typical signatures such as ice, dust, and outgassing. However, upon closer examination, we might notice subtle discrepancies, unusual chemical compositions, unexpected materials, and behaviors that appear more engineered than random. We would anticipate it possessing significant mass, far exceeding its visible dimensions, due to a dense, non-sublimating core that remains intact regardless of surrounding ice sublimation. Additionally, we might expect it to be transmitting signals, perhaps not overtly or loudly, but detectable if one knew precisely where to look, possessed the appropriate instruments, and directed them accurately at the opportune moment. A pulse, a pattern, an anomalous signal. Birdie Dworsky perceived all of these elements in August, before the majority of the scientific data was publicly disseminated, before the anomalies became undeniable, and before NASA fell silent. She described a message in a bottle journeying through the galaxy. And now, as 3I Atlas conceals itself behind the sun, as official sources decline to release images from the Mars flyby, and as amateur astronomers report observing cylindrical forms while scientists detect chemically impossible characteristics, that vessel approaches perihelion, the point of maximum heat, maximum stress, the point where, as Avi Loeb suggested, confessions are elicited. If a thumb drive-sized piece of technology is indeed embedded within the heart of this comet, October 29th will be the day it either reveals itself or remains concealed indefinitely. The fact that NASA furloughed 15,000 employees just prior to our most opportune observational window compels us to consider a question that remote viewers have been posing since August. What did they observe that we are not being shown? Chapter 3. NASA's Profound Silence. October 3rd, 2025, was anticipated to be a momentous occasion, the day humanity would achieve its closest observation of an interstellar visitor. The Mars Reconnaissance Orbiter was perfectly positioned. Its high-rise camera was prepared to capture imagery with a resolution 30 times superior to anything Hubble could achieve. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter were on standby, their full instrument arrays ready. Then, at the precise moment when NASA's capabilities were most critical, 83% of the agency effectively ceased operations. 15,000 civil servants were furloughed, absent during what should have been the most intense observational campaign in the history of interstellar astronomy. The official explanation provided was straightforward: a federal government shutdown due to budget impasses, entirely unrelated to Comet 3I Atlas. Merely unfortunate timing. The phrase "unfortunate timing" carries substantial weight in explaining why the world's leading space agency went dark precisely as an object exhibiting 7 statistically improbable characteristics passed within 29 million kilometers of our Mars spacecraft. Consider the statistical likelihood of such an event. 3I Atlas was discovered in July. The Mars flyby had been meticulously planned for months. Scientists understood this would represent their sole opportunity to capture high-resolution imagery before the object disappeared behind the sun. NASA was aware. ESA was aware. Every space agency globally was cognizant of this impending event, and in the final week leading up to the closest approach, the United States government initiated a shutdown. NASA's official website ceased updating. Press releases were suspended. The vast team of scientists who should have been actively analyzing data, processing images, and making groundbreaking discoveries were sent home. Only essential personnel remained to maintain critical operations. However, this situation is profoundly suspicious. Raw image feeds from the Perseverance rover continued to be uploaded. The rover did not cease functioning. The Mars Reconnaissance Orbiter remained operational. The cameras were active, and data was being collected. It was simply not being released to the public. Amateur astronomer Dobsonian Power, a YouTuber specializing in solar observations, posted an image on October 3rd with a concise caption, "What on earth is it?" The image depicted a dark, angular object embedded within the expected location of Comet 3I Atlas. Within hours, the post garnered thousands of views, with individuals demanding answers and questioning why, if a backyard observer could capture such an image, the sophisticated professional instruments were not producing comparable results. NASA remained silent. ESA offered no comment. The sole official confirmation that observations had taken place originated from Simeon Schmaus, the astrophotographer who stacked 20 Perseverance images and identified that faint smudge. He shared his findings on social media, not through official channels, but as a private citizen undertaking the work that space agencies seemingly neglected. Subsequently, during a White House press briefing, Stephen Miller, Deputy Chief of Staff for Policy, was discussing the government shutdown when a reporter posed a question that had been circulating online for days. "Has the president been briefed about 3I Atlas?" The room fell silent. Miller paused, carefully selecting his words, and provided a deflection. The briefing proceeded, but the question had been officially registered in a formal setting, rendering it impossible to dismiss as mere internet speculation. The United States government was directly queried about an interstellar object, and its response was a deliberate omission. Concurrently, Avi Loeb was making appearances on news networks, including Newsmax and CBS, and various podcasts, addressing anyone willing to listen. He meticulously detailed the anomalies with mathematical precision, highlighting the trajectory's alignment with the ecliptic plane, a probability of 0.2%, and the timing optimized for planetary encounters, a probability of 0.005%. The 7 attributes that rendered 3I Atlas unlike any celestial body previously documented were extraordinary. He consistently returned to a singular concern: the necessity of data from the Mars orbiter. The high-resolution imagery could ascertain the nucleus's dimensions and reveal internal structures, thereby answering the fundamental query regarding its true nature. Yet, these images remained unreleased. During a podcast with Brian Keating, Lowe disclosed that Representative Tim Burchett, a member of the House Committee on Oversight and Accountability, had appeared alongside him on Newsmax to discuss the object. The fact that a sitting congressman was publicly discussing an interstellar visitor and the subsequent official silence on national television elevated the conversation beyond fringe speculation, propelling it into mainstream political discourse. Despite this, NASA offered no comment. The European Space Agency eventually issued a statement confirming that its Mars Express and ExoMars Trace Gas Orbiter had successfully documented 3I Atlas during the observation window from October 1st to the 7th. Their instruments, including a high-resolution stereo camera, a color and stereo surface imaging system, and multiple spectrometers, had gathered data slated for analysis in the ensuing weeks, with results to be published when complete. However, there were no images, no preliminary findings, and no expression of excitement regarding the capture of unprecedented views of an interstellar object at its closest approach. It was merely a terse confirmation of observational activity, followed by silence. China's Tianwen-1 mission remained silent. The UAE's Hope orbiter offered no information. Every spacecraft orbiting Mars had been observing, yet every space agency on Earth had fallen silent. One need not be a conspiracy theorist to find this peculiar. Simply recalling the events surrounding Oumuamua, the preceding interstellar visitor, suffices. When it transited our solar system in 2019, images were disseminated immediately. Scientists expressed enthusiasm, press releases proliferated, and the astronomical community rejoiced. It was treated precisely as one would anticipate for a rare visitor from beyond our solar system, meriting intense scrutiny and public engagement. 3I Atlas, conversely, was met with silence. The distinction, perhaps, lies in Oumuamua's behavior, which aligned perfectly with that of a comet. Its chemical composition, visible tail, and outgassing patterns were all consistent with cometary activity. While its interstellar origin made it noteworthy, it was not anomalous. It did not challenge existing scientific understanding or provoke uncomfortable questions. 3I Atlas, however, does all of these things. Thus, as it receded behind the Sun en route to perihelion, entering the region of the solar system invisible to Earth-based telescopes, the silence intensified. Amateur astronomers shared their final captured images. Scientists published carefully worded, technically precise papers, refraining from speculation. Meanwhile, 15,000 NASA employees, granted essential status, awaited instructions regarding the Mars orbiter imagery their colleagues had observed, which remained withheld from public view. Chapter 4. 7 Impossible Occurrences. Science operates on a principle known as Occam's razor. When faced with competing explanations, the most straightforward one is typically accurate. A single anomaly can be dismissed. 2 might be attributed to coincidence. However, when 7 statistical improbabilities are superimposed, Occam's razor begins to suggest a different conclusion. Let us examine what makes 3I Atlas so distinct from any object previously tracked through our solar system. Anomaly 1. The Mass Conundrum. When astronomers initially estimated 3I Atlas's size based on its luminosity, they arrived at a figure that defied logic. If the observed light was solely reflected sunlight, the object would have had to span between 10 and 20 kilometers in diameter. For perspective, Oumuamua was scarcely 100 meters across, and 2I Borisov measured less than 1 kilometer. This object appeared to be orders of magnitude larger. Statistical models predicting the frequency of interstellar object detection are unequivocal. Small objects are prevalent, while large ones are exceedingly rare. We should have encountered hundreds, perhaps thousands, of Oumuamua-sized visitors before encountering something as substantial as 3I Atlas. The calculated probability of such an event was approximately 0.01%, or 1 in 10,000. Subsequently, the astrometric data emerged. Over 4,000 measurements, collected from 227 observatories between May and September, provided crucial insights. Upon analyzing the object's trajectory and comparing it to purely gravitational acceleration, scientists noted something remarkable: virtually no deviation. Despite substantial outgassing and the loss of 150 kilograms of material per second, the object adhered closely to its predicted path. This implied immense mass, a nucleus so considerable that continuous gas and dust expulsion failed to alter its course significantly. Calculations suggested a mass exceeding 33 billion tons and a diameter greater than 5 kilometers, making it not only larger than previous interstellar visitors, but approximately 1 million times more massive than Oumuamua. 1 million times. Consider that disparity. It is akin to comparing a grain of sand to a substantial boulder. Anomaly. 2. The sunward luminescence. Hubble captured the highest resolution image of 3I Atlas on July 21, 2025. Scientists analyzing this image observed a phenomenon never before documented in any comet, solar system, or interstellar object. The scattered light surrounding the object extended roughly twice as far towards the sun as it did perpendicularly or away from the sun. Comets exhibit tails directed away from the sun due to radiation pressure expelling dust particles. This is a fundamental principle of physics, confirmed by centuries of observation. 3I Atlas appeared to defy this principle, with the extension being not subtle, but a 10-to-1 ratio, 10 times longer in the solar direction than laterally. Furthermore, this observation was made edge-on, implying that the actual elongation was even more pronounced when accounting for the viewing geometry. Avi Loeb and Eric Key have co-authored a paper proposing an explanation involving ice fragments that sublimate at varying rates depending on the ejection side. While the physics and mathematics of their theory were sound, it necessitated a highly specific set of conditions, unlike any previously observed in other comets. It proposed a unique configuration that coincidentally occurred in an interstellar visitor already exhibiting multiple other anomalies. Anomaly 3. The industrial signature. In late August and early September, the Very Large Telescope in Chile focused its UV spectrograph on 3I Atlas and detected a substance that stunned scientists: nickel atoms within its gas plume. A substantial quantity of nickel was observed, rising exponentially as the object approached the sun, increasing by a power law of approximately 9. The critical issue, however, was the near absence of iron. Naturally, nickel and iron are co-produced in supernova explosions and typically appear in fixed ratios. Every naturally occurring comet ever observed exhibits similar abundances of nickel and iron. 2I Borisov, the prior interstellar comet, displayed normal nickel-to-iron ratios, as do all solar system comets. 3I Atlas, however, was producing nickel without iron. This specific signature is found exclusively in industrial processes, particularly in nickel alloys, materials that have undergone deliberate refining and separation. The scientists who published these findings exercised caution in their wording, describing the observation as extremely puzzling. They noted that the temperature at the object's distance from the sun was far too low to vaporize the refractory minerals containing these metals under standard conditions. While they proposed potential chemical pathways to explain this, an undercurrent of uncertainty was palpable in their explanations. Anomaly. 4. Polarization from an extraterrestrial source. When light interacts with particles, it becomes polarized. The degree and direction of polarization provide information about the size, shape, and composition of these particles. Comets possess characteristic polarization signatures, hundreds of which have been measured and thoroughly understood. 3I Atlas presented a polarization signature that existed in no known catalog, registering -2.77% at a phase angle of approximately 7 degrees, with an inversion angle of merely 17 degrees. This combination had never been recorded in any asteroid or comet, whether from our solar system or interstellar origin. The closest parallel was not with comets at all, but rather with trans-Neptunian objects and a specific centaur named Pholus, icy bodies originating from the outer solar system with vastly different compositions and histories than typical comets. A paper submitted to Astrophysical Journal Letters concluded that 3I Atlas might represent a distinct category of comet, thereby expanding the diversity of known interstellar entities. The phrase distinct type is scientific parlance for an entity that falls outside established classifications. Anomaly. 5. Ecliptic alignment. The solar system is fundamentally planar, with planets orbiting within a plane known as the ecliptic. Interstellar objects from random directions typically intersect this plane at random angles. The probability of an interstellar visitor's orbit aligning within 5 degrees of the ecliptic is approximately 0.2%, or 1 in 500. 3I Atlas arrived aligned within 5 degrees. Furthermore, its trajectory was retrograde, moving in opposition to the orbital direction of the planets. This represents an optimal trajectory for surveying multiple planets with minimal course corrections. Anomaly. 6. Planetary timing. 3I Atlas was predicted to pass close to 3 planets during its flyby: Venus at 0.65 astronomical units, Mars at 0.19 AU, and Jupiter at 0.36 AU. The probability of a random interstellar visitor arriving with timing that facilitates close encounters with 3 distinct planets is approximately 0.005%, or 1 in 20,000. If one were designing a reconnaissance mission to our solar system, this would be the precise trajectory to select. Anomaly. 7. The WOW signal coincidence. In 1977, the Big Ear radio telescope detected a signal so unusual that astronomer Jerry Amon famously scribbled "wow" in the margins. Originating from the constellation Sagittarius, the signal persisted for 72 seconds and has never been detected again, despite decades of searching. When scientists traced 3I Atlas's trajectory backward through the galaxy, factoring in its speed and direction, they calculated its position in 1977. The result placed it within 9 degrees of the origin of the WOW signal. The probability of this alignment is roughly 0.6%. 7 anomalies, 7 statistical longshots, and we are expected to accept them as mere coincidences. Chapter 5. October 29th. The Revelation. At this very moment, as you are listening, 3I Atlas is in a location beyond our observation, concealed behind the sun, progressing towards a point in space where physics exerts its most potent influence: perihelion, its closest approach to our star. For 3I Atlas, this event is scheduled for October 29th, 2025, at a distance of approximately 1.4 astronomical units, just within the orbit of Mars. This proximity means the sun transitions from a distant light source to an overwhelming presence. Imagine standing before an open blast furnace. Now, amplify that heat by an incomprehensible factor. That is the reality of perihelion for an object emerging from the frigid darkness of interstellar space. The sun's rays will bombard its surface with gigawatts of power, not metaphorical power, but actual, measurable watts, equivalent to the energy that powers entire cities. Avi Loeb made an observation that resonated deeply. High-stress environments compel confessions. He was discussing interrogation techniques, but the principle extends to physics as well. When ice is heated, it cannot maintain a pretense of being anything other than ice. When rock is heated, it behaves as rock. And when an object that purports to be a comet, but might be something else entirely, is subjected to intense heat, its facade crumbles. Two distinct scenarios exist for what transpires at perihelion, and they are diametrically opposed. Scenario 1. 3I Atlas is precisely what it appears to be: a comet. An unusually massive, chemically anomalous, statistically improbable comet, but natural nonetheless. In this scenario, October 29th marks the commencement of extraordinary activity. Surface temperatures will rise. Volatiles dormant for billions of years will be exposed to solar radiation, causing carbon dioxide to sublimate and water ice to vaporize. Dust particles will be ejected in massive plumes. We have witnessed this phenomenon before. Comets nearing perihelion become spectacular, developing tails millions of kilometers long and increasing dramatically in brightness. Occasionally, they fragment under the stress, breaking into pieces that eventually disperse. It is a violent, chaotic, and profoundly beautiful spectacle. If 3I Atlas is a natural object, we should anticipate a similar event: a significant outburst of gas and dust, a brightness increase of tenfold or more, and the formation of a proper tail, not the anomalous sunward glow, but a classic cometary tail streaming behind it as radiation pressure exerts its force. Furthermore, if the object is as fragile as some scientists suspect, with its 5-kilometer diameter composed largely of loosely bound ice rather than solid rock, perihelion might cause its complete disintegration. We could witness in real time the disintegration of an interstellar visitor into fragments, offering an unparalleled glimpse into the internal structure of a comet from another star system. This would be an extraordinary scientific boon, answering questions about comet formation, the composition of planetary systems beyond our own, and the processes that propel objects into interstellar space, even if it leads to the object's destruction. However, there is scenario 2. 3I Atlas is not natural. The anomalies are not coincidences. The presence of nickel without iron, the retrograde tail, and the precise alignment with the ecliptic and the wow signal's origin all signify something profound. In this scenario, perihelion is not about sublimation, but about activation. Consider what steps one would take if tasked with dispatching a probe to another star system. It would need to endure the interstellar journey, billions of years in the cold, exposed to radiation, impacts, and the slow decay of time. Encasing it in ice would be logical. Ice is abundant, offers protection, and would make the probe appear natural to any civilization that might detect it before it was intended to be discovered. However, once this probe reached the inner solar system and approached the host star, it would need to activate. It would require power, and the star would be the sole available source. In this scenario, perihelion serves not as a stress test, but as a charging station. Lowe has meticulously detailed these possibilities in his papers with mathematical precision. The object could employ a solar orbital maneuver. This is a genuine technique utilized by our own spacecraft. One dives close to the sun, leverages its gravity for acceleration, and dramatically alters trajectory with minimal fuel expenditure. It represents the most efficient method for changing course within the solar system. The optimal juncture for this maneuver is at perihelion, and 3I Atlas reaches perihelion while completely obscured from Earth-based observation, hidden behind the sun. This would be the opportune moment to alter course without detection. Alternatively, it could deploy something: mini probes, small craft that detach and utilize the retrograde trajectory to intercept planets, Mars, Earth, Jupiter, all reachable from this position with minimal course adjustments. The precise timing of the planetary alignments renders this almost trivially achievable compared to random arrival times. Lowe has carefully considered the implications. If 3i Atlas maneuvers towards Earth upon reappearing on the other side of the Sun, financial markets could plummet. This is not hyperbole, but a sober assessment of the potential consequences when humanity confronts the reality of not being alone, and the visitors might not be benevolent. However, we will not know, not yet, because between now and early December, we are effectively blind. Every telescope on Earth, every space-based observatory, cannot see behind the Sun. 3i Atlas is in a communications blackout, ideal for a spacecraft that wishes to conceal its next move. The European Space Agency has a contingency plan. Between November 2nd and the 25th, the Jupiter Icy Moons Explorer, JUICE, spacecraft, currently en route to Jupiter, will orient its instruments towards 3i Atlas. JUICE will intercept the object shortly after perihelion, when it is expected to be at its peak activity, and after whatever significant events are to occur have already transpired. JUICE was not designed for comet studies. Its cameras and spectrometers are optimized for icy moons, for detecting subsurface oceans, and for analyzing the chemistry of alien water. Nevertheless, these same instruments can observe 3i Atlas. Furthermore, because JUICE is positioned between Earth and the Sun, it possesses a viewing angle unavailable from our planet. If the object develops a substantial coma and tail, JUICE will observe it. If it fragments, JUICE will document the debris field. And if it performs any unexpected actions, if it maneuvers, deploys objects, or exhibits any behavior inconsistent with a natural comet, JUICE will record that as well. The data transmission will not be instantaneous. Space communications are time-delayed, and JUICE is far from home. However, by late November or early December, we will have answers. This coincides with 3i Atlas's reemergence into Earth's visible spectrum. December 19th marks the object's closest approach to our planet, still 1.8 astronomical units away. It poses no immediate threat, but it will be close enough for every major observatory to track its trajectory with extreme precision. This is when we will ascertain if anything has changed. If the orbit aligns precisely with predictions from gravitational models, we can find relief. It will be another interstellar visitor, peculiar but natural, continuing its journey back into the cosmic void. However, if the orbital data deviates, if the trajectory shows even slight discrepancies inexplicable by outgassing or solar radiation pressure, then every assumption we hold about our place in the universe will necessitate reevaluation. October 29th is the day 3i Atlas will reveal its true nature. However, we will not learn of this revelation until December, and by then, it may be too late to do anything but observe the unfolding events. Chapter 6: The Global Frenzy. While scientists engaged in data debates and NASA maintained its reticence, an independent phenomenon was gaining momentum, spreading with unprecedented speed, far outpacing the peer review process for any scientific publication. The Internet was ablaze. The phenomenon began in the United States, as such trends often do. TikTok videos featuring alleged images of 3i Atlas, some genuine, many fabricated, collectively amassed millions of views. Reddit threads expanded exponentially, accumulating thousands of comments. Twitter, now known as X, transformed into a battleground between amateur astronomers sharing authentic observations and influencers seeking engagement with increasingly outlandish claims. However, America was merely the starting point. In India, the narrative mutated into something entirely different. WhatsApp, the primary communication platform for hundreds of millions, became a conduit for rumors that outpaced the efforts of fact-checkers. Forwarded messages in Hindi described an alien spacecraft in disguise. Videos narrated with urgent tones asserted that the object was altering its course. Screenshots of fabricated news articles bearing headlines designed to instill fear circulated widely. One particularly viral forwarded message alleged that world governments were already engaged in negotiations with the entity or entities aboard 3I Atlas. Another suggested covert military mobilizations were underway. A third displayed an altered image purportedly from NASA, watermarked classified, depicting a geometric structure in place of the comet. None of this information was factual, yet it all spread regardless. Hindi-language YouTube channels experienced an explosion of content. Some offered earnest attempts at scientific communication, explaining the nature of an interstellar object. Others, however, leaned heavily into speculation, blending legitimate astronomical facts with ancient astronaut theories and prophecies. The distinction between education and entertainment dissolved entirely. Brazil experienced similar dynamics unfolding on Telegram and Facebook. Communities of UFO enthusiasts, already predisposed to identifying patterns in the sky, entered a state of heightened activity. Groups that had spent years analyzing aerial phenomena over the Amazon now had a concrete subject for their scrutiny. A genuine artifact from beyond our solar system, displaying conduct that perplexed even seasoned scientists. The conspiracy landscape in Brazil is remarkably dynamic. It merges indigenous lore, Catholic spirituality, and contemporary UFO legislation into something that resists simple classification. The object known as 3 Atlas became all things to all people, a precursor to the end of days, a craft carrying advanced beings intent on humanity's salvation, a weapon, a bestowal, a trial. Online discussion platforms saw an influx of new participants. Live broadcasts dissecting the celestial body ran for extended periods, with presenters reading scientific dissertations aloud, only to immediately transition to theories far exceeding the scope of the cited research. The comment sections functioned as digital gathering places where thousands shared anxieties and conjectures in equal measure. The United Kingdom, with its extensive history of investigating crop circles and recent UFO sightings, approached the phenomenon of 3 Atlas with a blend of doubt and curiosity. British tabloids published headlines that navigated a fine line between sensationalism and plausible deniability, suggesting that a colossal comet might be evidence of alien engineering. The scientists referenced in these reports were typically quoted out of context, but the headlines served their purpose. Russia, as might be expected, viewed the entire situation through a geopolitical prism. Official media outlets briefly acknowledged the object, always careful to highlight perceived American indecision and confusion. Some suggested that Western nations were fabricating a crisis to justify increased defense expenditure. Others obliquely implied that the American government possessed undisclosed knowledge, perhaps even that clandestine American projects had established contact. Russian online forums buzzed with technical debates. While the astronomical knowledge displayed was frequently impressive, it was interwoven with hypotheses linking 3 Atlas to various covert space programs, recovered extraterrestrial technology, and ancient conspiracies dating back to the Soviet era. Then came the incident involving Michio Kaku. A circulated screenshot appeared to show the theoretical physicist in what seemed to be a television interview. Text overlaid on the image claimed he had stated that 3 Atlas was en route to execute a reconnaissance mission, possibly with hostile intentions, under the caption, "It might be an alien probe sent to Earth." The image itself was genuine, but its context was fabricated. Fact-checkers traced the screenshot back to a broadcast on Nation News from February 20th, 2025, months before 3 Atlas was even discovered. Kaku had been discussing an entirely different subject, likely an asteroid impact scenario. Someone had superimposed false text onto his image and disseminated it widely. The authenticity of the claim was irrelevant. The post garnered over 290,000 views before platforms began to flag it. By then, it had been screenshotted and reshared countless times, each reproduction obscuring its origin. The account responsible, Lord Bebo, never issued a retraction. The damage was irreversible. Thousands of individuals now believed that a respected physicist had affirmed 3 Atlas to be hostile alien technology. NASA attempted a response. Their official solar system account posted on September 30th, stating, "Comet 3I Atlas poses no threat to Earth. It will remain hundreds of millions of kilometers away from our planet. This is a natural interstellar object, extremely rare and scientifically valuable, but not dangerous." The reaction was swift and laced with skepticism. If it were merely a comet, why the extensive security measures? If it posed no danger, why the official silence? If it were natural, how could the absence of iron alongside nickel be explained? NASA did not engage further. The statement stood in isolation, a solitary tweet against a deluge of speculation. Al Jazeera's fact-checking division, Sanad, published a comprehensive investigation. They corroborated the existence of 3 Atlas, discovered by the Atlas telescope on July 1, 2025. They verified that it presented no danger, with its closest approach to Earth remaining approximately 270 million kilometers. They debunked the Kaku quotations, the claims of military mobilization, and the rumors of secret negotiations. Their fact-check was a model of journalistic integrity. It likely swayed very few opinions. Because while Sanad was meticulously verifying facts, Avi Loeb was addressing the United Nations, not in an official capacity within the General Assembly, but through discussions with delegates, in papers circulated among policy advisors, and in hushed meetings where the term existential was used without any hint of irony. He presented his concept of a black swan event, the notion that low probability, high impact occurrences necessitate preparedness, particularly when they seem improbable. A black swan event is defined as something that appears impossible until it occurs, after which it seems remarkably obvious in retrospect. This concept, originally developed by Nassim Taleb to explain financial collapses, was applied by Loeb to the possibility of interstellar visitors. We tend to assume all such objects are natural because we have only encountered natural ones. But what transpires when that assumption is invalidated? The hashtag #TheHarbinger began trending, not across mainstream feeds, but within specific communities fixated on 3 Atlas. The term originated from ancient texts and prophecies describing celestial messengers, harbingers of change, judgment, or transformation. Some interpreted it literally, with end times theology aligning surprisingly well with an interstellar object exhibiting inexplicable traits. Others employed it metaphorically, signifying a harbinger of a new era in space exploration or humanity's realization of a universe far more populated than previously imagined. Amidst this atmosphere of apprehension, conjecture, and outlandish theories, one voice consistently emerged in the discourse, that of Stefan Burns, the cosmologist mentioned by Moneypenny. Claims circulated suggesting he believed 3 Atlas to be sentient, to exhibit consciousness, and to be actively communicating with us and other celestial bodies. No verifiable source could be found for Burns's pronouncements, no published research, no interviews, only second-hand accounts and enigmatic social media posts. Yet, the idea resonated because it seemed to fit seamlessly with all other unfolding developments. The anomalies, the pervasive silence, the palpable sense that events were transpiring just beyond our clear perception. Chapter 7. December's verdict. In early December of 2025, 3 Atlas would re-emerge from behind the sun, much like a swimmer surfacing after a prolonged dive. Astronomers would locate it within the constellation Virgo, positioned low on the eastern horizon during the pre-dawn hours. Its apparent magnitude would be around 12 or 13, still too faint for amateur telescopes, but well within the range of professional observatories. All eyes would be on the numerical data. Orbital mechanics stands as one of our most precise scientific disciplines. Newton's laws, refined by Einstein's theory of relativity, enable us to forecast an object's position years in advance with kilometer-level accuracy. We can account for gravitational influences from planets, the pressure exerted by solar radiation, and even the subtle force of outgassing as comets shed material. When 3 Atlas reappeared, its precise location would reveal a narrative. If it adhered exactly to predictions derived from purely gravitational calculations, allowing for expected deviations due to outgassing, then we could reasonably conclude that nothing extraordinary occurred during its passage behind the sun. It would have completed its perihelion, withstood the solar heat, and continued on its predetermined trajectory into the outer solar system, eventually returning to interstellar space. However, if its position deviated, if its trajectory exhibited changes unexplainable by known forces, then every scientific paper concerning this object would necessitate a supplementary addendum. Every assumption would be challenged, as celestial bodies do not alter their course spontaneously. Something must exert the necessary force. The Vera C. Rubin Observatory would play a pivotal role in subsequent developments. This telescope, which only recently commenced operations, represents a paradigm shift in our approach to surveying the cosmos. Previous asteroid surveys identified approximately 20,000 new objects annually. In its initial 10 hours of operation, Rubin detected 2,140 asteroids, 10 hours yielding 2,000 asteroids. The implications are profound. When Rubin directs its observational capabilities towards the detection of interstellar objects, the current trickle will transform into a torrent. Scientists estimate that we could be identifying dozens of interstellar visitors each year, rather than one every few years. Each of these would be meticulously studied, drawing upon the lessons learned from 3 Atlas. We would know precisely what to seek: chemical signatures, polarization characteristics, trajectory alignments. If 3 Atlas is indeed anomalous, we would have other objects for comparative analysis. If it represents the first of a new category, Rubin would undoubtedly discover its counterparts. Yet, December's significance extends beyond orbital mechanics and future surveys. It pertains to questions that have been accumulating since July. What precisely did the Mars orbiters observe? By December, the government shutdown would have long concluded, and NASA would be operating at full capacity. The high-resolution images captured on October 3rd would have undergone processing, analysis, and either been archived or prepared for public release. These images, taken when 3 Atlas was a mere 29 million kilometers from the cameras, possessed the potential to resolve features on the nucleus, provided the coma was not excessively dense. A 5-kilometer-wide object at that proximity should exhibit discernible structure, not intricate detail, but fundamental morphology. Is it spherical, elongated, or irregular? Are there variations in brightness that suggest the presence of different surface materials? Does its appearance align with other comet nuclei we have photographed, or is it something entirely different? The continued withholding of these images raises persistent questions that will not simply vanish with the turning of the calendar to December. Scientific data is typically disseminated with utmost urgency. The competition to be the first to announce new findings is exceptionally fierce. The fact that multiple space agencies observed 3 Atlas near Mars, and none have released detailed imagery, suggests either an unprecedented level of coordinated silence, which seems improbable, or that the observations necessitate careful deliberation before public disclosure. December will compel a resolution regarding this reticence. Either the images will emerge, confirming it as merely an unusual comet, or the absence of such images will become its own definitive answer. Radio astronomers will also be closely monitoring the situation. The connection to the WOW signal is either a mere coincidence or it is not. If 3 Atlas was the source in 1977, and if it remains capable of transmission, December offers another opportunity for detection. Numerous radio telescopes have been quietly observing the region where 3 Atlas is expected to be. This surveillance is being conducted not with the fanfare of typical SETI campaigns, but with patient, sustained observation. Any signal, any pulse, any discernible pattern in the radio frequencies that correlates with the object's position would be revolutionary. The hydrogen line at 1,420 MHz is the frequency to scrutinize. It was at this frequency that the WOW signal was detected. It is the frequency any civilization seeking to communicate would likely utilize, as hydrogen is the most abundant element in the universe, and its spectral line is a universal constant. If 3 Atlas has a message to convey, this is where it would be transmitted. December 19th marks the moment of closest approach to Earth, at 1.8 astronomical units, approximately 270 million kilometers. For context, this distance is about 1.5 times that between the Earth and the Sun. By no measure that signifies safety concerns, but it is sufficiently close for parallax effects to become significant. Parallax refers to the apparent displacement of an object when viewed from different vantage points. As the Earth traverses its orbit around the Sun, our viewing angle of 3 Atlas subtly shifts. By measuring this shift with exceptional precision, we can triangulate the object's exact distance and velocity. Any deviation from the predicted values would become immediately apparent. Observatories across the globe will coordinate their efforts, spanning both the northern and southern hemispheres and various longitudes, ensuring continuous coverage. Amateur astronomers will contribute data alongside their professional counterparts. This observation promises to be one of the most thoroughly documented of any solar system object in recorded history. And somewhere within this wealth of data, we will find either confirmation or contradiction. Confirmation that, despite all indications to the contrary, this is indeed a natural object from interstellar space exhibiting rare but explainable characteristics, an envoy from another planetary system, remarkable because it formed under conditions distinct from those of our solar system's comets, but ultimately governed by the same physical laws. Or contradiction. Something within its trajectory, its chemical composition, or its behavior that cannot be reconciled with natural origins, a data point that shatters the prevailing model, evidence compelling us to confront what we have been reluctant to consider. By late December, 3 Atlas will begin to fade again as it recedes from the Sun, venturing into the constellation Leo, and commencing its journey back toward the orbit of Jupiter, which it will traverse in March of 2026. Subsequently, it will enter the outer solar system and eventually interstellar space. One way or another, December will provide answers. Not all of them, perhaps, but enough to discern whether we are witnessing the most spectacular comet display of our generation or the most profound upheaval in human understanding since the realization that Earth was not the center of the universe. The telescopes are prepared, the equations are ready, the world is watching. Now, we await 3 Atlas's emergence from behind the Sun to reveal its true nature. Chapter 8. the scientific conundrum. Let us delve deeper into the scientific enigmas that are keeping astronomers awake at night. We will set aside speculation and conjecture to focus on the actual measurements that stubbornly defy consistent interpretation, regardless of how many times the calculations are rerun. Let us begin with the WOW signal. On August 15, 1977, the Big Ear radio telescope at Ohio State University was engaged in a routine SETI survey when it detected an anomaly that defied conventional explanation. A narrow band signal at 1420.4 megahertz, precisely the frequency expected for an artificial transmission. It persisted for 72 seconds, the exact duration required for the telescope's beam to sweep across a stationary source as the Earth rotated. The signal was exceptionally strong, registering 30 times louder than the ambient background noise. Upon examining the printout, the intensity values ascended from the typical 1s and 2s, climbed through the 5s and 6s, and peaked at U, the highest designation the system could produce, before exhausting its alphanumeric characters. Astronomer Jerry Amon, observing these escalating values, scribbled a single word in the margin: "Wow." Subsequent attempts to locate it yielded nothing. For years, even decades, the Big Ear telescope was directed at that precise patch of sky hundreds of times. Other observatories joined the search. The signal never reappeared. Eventually, it became astronomy's most perplexing mystery. Evidence of nothing, proof of nothing, yet impossible to forget. Now, let us trace 3 Atlas backward through the vastness of space. Accounting for its velocity of 60 kilometers per second, we map its trajectory through the galaxy. In 1977, it would have been approximately 600 astronomical units from Earth, 600 times the distance from Earth to the Sun, or 90 billion kilometers away. At such a distance, generating a signal as powerful as the one detected by Big Ear would necessitate a transmitter outputting between 0.5 gigawatt and 2 gigawatts of power. This is not the output of a battery or a generator. It is the power of a nuclear reactor. This sustained output would need to be focused into a beam narrow enough to traverse 90 billion kilometers and still register 30 times above background noise. Could a comet achieve this feat? Not according to our current understanding of physics. Comets do not generate gigawatts of power. They do not emit coherent radio signals. They do not broadcast at the precise frequency that coincidentally serves as the universal marker for technological civilizations seeking contact. However, an object intentionally designed to be discovered, an object intending to announce its presence before entering the inner solar system, would transmit in precisely this manner: one potent pulse, sufficient to be unmistakable, followed by silence to avoid prematurely revealing its position until it was ready. Now, let us consider the chemical analysis from the Very Large Telescope data, revealing nickel devoid of iron. In nature, these two elements are inextricably bonded from their inception. When a massive star undergoes a supernova, it forges heavy elements within its cataclysmic inferno. Nickel-56 decays into iron-56. They are created through the same nuclear processes, bound within the same mineral structures, and released into space as an inseparable pair. Every meteorite, asteroid, and comet ever analyzed exhibits them together. The proportions may vary slightly depending on the environment, but both elements are invariably present. 2. I. Borisov, originating from interstellar space just like 3 Atlas, displayed normal nickel-iron ratios. Comets within our solar system also show normal ratios. There exists no natural process at the temperatures experienced by 3 Atlas that can segregate these elements. However, refinement, smelting, chemical processing, industrial production of nickel alloys, often involves the removal of iron contaminants. We perform this on Earth daily, producing high-purity nickel for electronics, specialized alloys, and applications where iron would be detrimental. This process leaves a distinct signature: nickel without iron. The scientists who published this data from the VLT exhausted every conceivable natural explanation. Perhaps unusual chemical pathways within the ice, perhaps exotic minerals formed under conditions previously unknown, perhaps dust grain physics not yet fully understood. Every hypothesis encountered the same insurmountable obstacle. The temperature is too low, the environment is unsuitable. This phenomenon should not be occurring. Furthermore, it is not a static observation. The production of nickel increases exponentially as the distance from the sun decreases, following a power law of approximately 9. This signifies that for every 10% closer the object approaches, its nickel output escalates dramatically. This is not random outgassing. It is a process that intensifies with increasing solar energy, almost as if something is powering on. Then there is the tail, pointing in the incorrect direction, violating one of the most fundamental and reliable principles in planetary science. Solar radiation pressure is not a subtle force. When photons from the sun strike dust particles, they impart momentum. It is a minuscule push, yet relentless. Over time, it overcomes the weak gravitational pull of a comet and propels dust particles away from the sun. Every comet ever photographed exhibits this characteristic. The tail invariably points away from the sun. Always, except that 3 Atlas displays scattered light extending twice as far toward the sun as away from it. The Hubble image is unequivocal. Enhancement of the data renders it even clearer. There is more material-oriented sunward than anti-sunward. Avi Loeb and Eric K.H. Chung published a model proposing that this could occur if the object sheds large ice fragments from its sun-facing hemisphere, and these fragments persist longer due to their size, creating an extended snow line in the solar direction. The physics, when applied to paper, is sound. It relies on ice fragments of specific sizes being ejected at specific velocities under precise solar heating conditions. However, these conditions are extraordinarily narrow. It necessitates preferential ejection from the day side, requires the fragments to be substantial enough to resist radiation pressure, yet small enough to efficiently scatter visible light, and demands an evaporation rate precise enough for the fragments to endure long enough to produce the observed distribution. It is, at best, a remote possibility, akin to flipping a coin 50 times and achieving heads on every occasion. The laws of physics do not prohibit it, but the statistical improbability raises questions about the coin's fairness. And this is the recurring pattern. Each anomaly presents a natural explanation that holds true, provided one is willing to accept that 3 Atlas possesses a unique configuration unlike any comet ever observed. Its mass can be accounted for by assuming uncommon density. Its trajectory can be explained by a statistical anomaly. Its chemistry can be rationalized by invoking exotic processes. Its polarization can be attributed to dust grain distribution dissimilar to anything catalogued. Each explanation is plausible in isolation, but they are not truly isolated. They accumulate. 7 anomalies, each demanding its own special pleading, all occurring within the same object. At what point does the simplest explanation cease to be natural and begin to suggest deliberate design? This is the crucial question perplexing scientists as a trio of celestial bodies obscures the sun. As of October 1st, 2025, an object traversed within 250 miles of Earth. At such an altitude, astronauts inhabit and operate the International Space Station. Commercial satellites maintain their carefully charted orbits, but this particular entity, identified as asteroid 2025 TF, remained entirely undetected. We became aware of its presence a mere 6 hours after it had already rocketed past us at a speed exceeding 13,000 miles per hour, passing just above the South Pole. Take a moment to contemplate this. A celestial fragment roughly the size of a small automobile, traveling at a velocity superior to any projectile, passed through the very same aerial domain where humanity conducts its most advanced endeavors. And we had absolutely no forewarning. Meanwhile, on the Martian surface, our exploratory vehicles have unearthed what researchers are characterizing as the most unequivocal evidence of ancient life ever encountered. These patterns, akin to leopard spots frozen in time, may well establish that we have never been alone. Congressional inquiries have just brought to light footage depicting a military ordnance impacting an unidentified object off the coast of Yemen. Curiously, the object did not detonate. It continued its flight. The sun is presently entering a phase that physicists term a final gasp, which could illuminate our skies with auroras of unprecedented intensity, surpassing anything witnessed in decades. 3 comets are currently on a trajectory towards us, their coloration shifting to green as they draw nearer, with one potentially becoming visible to the unaided eye within weeks. NASA has reduced its workforce by 15,000 employees while engaged in a race with China to reach the moon, and a private enterprise is on the verge of launching the most powerful rocket ever constructed, possibly for its final trial, before a complete redesign. This is not a work of speculative fiction. This is October of 2025. If you are prepared to delve deeply into what is truly transpiring directly above us, please engage the like button and subscribe, as we are about to dedicate the subsequent 2 hours to dissecting the most remarkable astronomical news of our era. Share in the comments section your point of origin, the current time there, and which of these narratives most astonishes you. And if you wish to contribute to the expansion of our community, kindly disseminate this information on X, Facebook, Reddit, or your preferred messaging platform. We express our gratitude for your unwavering support. Let us commence with the asteroid that eluded our defenses. Chapter 1. Close Encounter. The asteroid that surprised humanity. We have allocated billions of dollars to establish a planetary defense network. Telescopes positioned globally meticulously scan the nocturnal firmament, cataloging every moving celestial body, calculating their paths, and ensuring that no perilous object approaches without prior notification. This system functions with exceptional efficacy for substantial asteroids, the kind capable of devastating cities or even entire civilizations. We monitor these well in advance, often months or years ahead. However, on October 1st, 2025, our comprehensive detection apparatus failed to register an object until it had already receded from our view. Asteroid 2025 TF measures somewhere between approximately 1.2 and 2.7 meters in diameter. While not precisely a world-ending threat, it is comparable in size to a compact car. Its velocity was 20.9 kilometers per second, which translates to nearly 13,000 miles per hour, swift enough to traverse the United States in under 4 minutes. At its closest point of approach, shortly after midnight UTC on October 1st, this rock passed 419 kilometers above Antarctica. To provide context, the International Space Station orbits at approximately 420 kilometers. This asteroid navigated the very vicinity where astronauts reside. The Catalina Sky Survey in Arizona detected it at 2:35 a.m. Eastern Time on October 1st, utilizing the Bokeh telescope at the Kitt Peak National Observatory. However, here is the aspect that should cause concern. that detection occurred 6 hours and 36 minutes after the asteroid's closest passage. We did not observe its approach. We observed its departure. Currently, asteroid 2025 TF ranks as the second closest asteroid flyby ever documented. The previous record holder, asteroid 2020 VT4, passed even nearer in November 2020, coming within 370 kilometers of Earth's surface. Yet, that object was also identified after the fact. There is a discernible pattern, and it is not an encouraging one. The issue is not one of inadequacy. The astronomers and engineers overseeing these detection systems are among the finest in their fields. The challenge lies in the fundamental principles of physics and available resources. Small asteroids like 2025 TF are exceptionally difficult to pinpoint. They are dark, they move at high speeds, and they reflect minimal sunlight. Our telescope arrays are calibrated to detect larger objects, those exceeding 150 meters, that would inflict widespread devastation. We meticulously track those. However, objects in the 1 to 10 meter range, numbering in the millions, are virtually invisible until they are almost upon us. Herein lies a more intriguing detail. Once asteroid 2025 TF was finally detected, scientists had to work in reverse to ascertain its orbital path. They determined that it follows an elongated trajectory around the Sun, with a semi-major axis of 1.62 astronomical units. Its orbit brings it as close as 0.676 astronomical units to the Sun at its perihelion, and as far as 256 astronomical units at its aphelion. The orbital period is approximately 2.06 years, and its orbit is inclined at roughly 9.1 degrees relative to the ecliptic plane, the flat disk where most planets orbit. Nevertheless, all these figures are subject to considerable uncertainty. The orbit is what astronomers term poorly constrained, with a condition code of 7. This signifies that the calculations are based on an observational arc of only 1 day, a snapshot so brief that predicting this asteroid's future position is more speculative than scientific. Further observations will be necessary to refine its trajectory and evaluate any potential threat during subsequent encounters with Earth. Consider the implications. An object passed closer to Earth than some of our satellites, and we possess only a rudimentary understanding of its origin or its future trajectory. It could return. It might be on a collision course with Earth decades from now, or it may never approach us closely again. We simply do not possess this knowledge. The unsettling reality is that asteroids of this magnitude impact Earth more frequently than most individuals realize. The Tunguska event in 1908, which flattened 830 square miles of Siberian forest, was likely caused by an object measuring only 30 to 50 meters across. While larger than 2025 TF, the difference is not substantial. Had 2025 TF been on a direct impact course, rather than a flyby trajectory, it would have detonated in the atmosphere with a force equivalent to several kilotons of TNT. Not enough to end civilization, but certainly sufficient to devastate a city if it detonated overhead. And we would have had no prior indication until it was too late. Scientists are deeming this incident a wake-up call. The near miss has rekindled discussions regarding the enhancement of our detection capabilities for smaller near-Earth objects. Because if there is one certainty, it is that our cosmic neighborhood is considerably more active and perilous than our current systems are equipped to fully monitor. The question is not whether another asteroid will surprise us. The question is when, and whether we will be fortunate enough for it to miss us again. However, while we are preoccupied with objects traversing near Earth, something far more profound has been unfolding on the surface of Mars. Something that could potentially answer one of humanity's most enduring inquiries. Chapter 2: The Mars Breakthrough, Ancient Life's Smoking Gun. For over a year, a rock on Mars has kept scientists engrossed, not due to its unusual size or composition, but because of what is inscribed upon its surface. These are patterns that, on Earth, would be unequivocally recognized as indicators of life. On September 10, 2025, NASA issued an announcement that sent reverberations throughout the scientific community and beyond. The discovery by the Perseverance rover of potential biosignatures within a sample designated Sapphire Canyon has withstood the most stringent scientific scrutiny imaginable, including peer review and publication in the esteemed journal Nature. Acting NASA Administrator Shay Duffy stated unequivocally, "This could very well be the most compelling evidence of life that we have ever uncovered on Mars." Let us rewind to July 24, 2024, when Perseverance drilled into an arrowhead-shaped rock, colloquially known as Chava Falls, located within Mars's Jezero crater. The rover's instruments promptly detected something intriguing. The rock's surface was adorned with formations that scientists began referring to as leopard spots, small circular features with lighter centers surrounded by darker borders. These were not merely decorative patterns. They represented chemical signatures that, on Earth, are frequently produced by microbes consuming organic matter and excreting specific minerals as byproducts. The spots contain vivianite and grayite, two minerals that form in water-rich environments at low temperatures. Vivianite is a hydrated iron phosphate often found in proximity to decaying organic matter and sediments. Grayite is an iron sulfide that certain types of microbial life generate as a metabolic byproduct. The co-occurrence of these minerals, alongside organic carbon, constitutes what geologists refer to as a compelling potential biosignature. However, the narrative becomes even more captivating. Chava Falls is situated within a geological formation named Bright Angel, located along the margins of Nuret Valles, an ancient river valley that once conveyed water into Jezero crater over 3 billion years ago. This valley, approximately a quarter-mile wide, suggests sustained, powerful water flow over extended periods. The mudstones and layered sediments within Bright Angel recount the history of a dynamic environment where rapid river currents alternated with periods of calm, standing water, precisely the kind of milieu where microbial life thrives on Earth. The discovery was particularly surprising as Bright Angel represents some of the most recent sedimentary rocks investigated by the Perseverance mission. Earlier hypotheses posited that evidence of ancient life would be confined to older rock strata, remnants of Mars's earliest and most habitable epoch. However, finding these features in comparatively younger rocks suggests that Mars may have retained habitability for a longer duration than previously assumed, or that life persisted later into the planet's history than we had imagined. Before we become overly enthusiastic, it is imperative to clarify the meaning of a potential biosignature. This is not definitive proof of life. It is evidence necessitating further investigation. As mission scientist Katie Stack Morgan emphasized, astrobiological assertions, particularly those pertaining to the potential discovery of past extraterrestrial life, demand extraordinary substantiation. The rigorous peer review process that culminated in publication in Nature involved external scientists dedicating an entire year to meticulously scrutinizing the Mars 2020 team's data and analysis. They sought alternative explanations, non-biological processes that could account for the observed patterns. While some possibilities were identified, none aligned with the evidence as compellingly as the biological hypothesis. Herein lies the significance of this discovery. The Perseverance rover employed two sophisticated instruments to analyze Chava Falls. Sherlock, an acronym for scanning habitable environments with Raman and luminescence for organics and chemicals, detected a potent spectral signature known as the GAND, indicative of organic carbon. PXL, the planetary instrument for X-ray lithochemistry, meticulously mapped the distribution of chemical elements across the rock's surface with exceptional precision. Collectively, these instruments revealed that the organic matter and the redox-sensitive minerals were not merely present. They were co-located within the same minute spots, clustered in a manner strongly suggesting a correlation. On Earth, this type of co-location is commonplace in microbial ecosystems. Bacteria metabolize organic compounds and excrete minerals as waste. These minerals precipitate precisely where the microbes are situated, forming distinctive patterns. The leopard spots on Cheva Falls bear a striking resemblance to features found in ancient terrestrial rocks where microbial activity is known to have occurred. However, there is a significant caveat. To definitively ascertain whether these features possess a biological origin, scientists must transport the Sapphire Canyon sample back to Earth, where it can be subjected to analysis by instruments far more advanced than any we can deploy on Mars. Terrestrial laboratories can conduct isotopic analysis, examine the molecular structure of organic compounds, and perform experiments that are simply unfeasible with a rover's limited capabilities. This is where the political dimension of the narrative emerges. The Mars Sample Return Mission, a collaborative initiative between NASA and the European Space Agency, was conceived precisely for this purpose: to retrieve the samples meticulously collected by Perseverance and deliver them to terrestrial laboratories. However, the mission has been plagued by budget overruns and schedule delays. President Trump's proposed budget for 2026 would entirely discontinue the current Mars Sample Return Program, eliminating its funding. During the September press conference announcing the Cheva Falls findings, Duffy indicated that this was not an abandonment of the objective, but rather a strategic shift towards identifying a more cost-effective and expeditious alternative. Concurrently, China has announced its own plans for a Mars Sample Return mission, potentially launching as early as 2028. If the United States fails to retrieve Perseverance's samples, China may be the first to bring Martian material back to Earth, and they may be the ones to definitively answer whether life ever existed on Mars. The geopolitical ramifications are profound. For the present, the Sapphire Canyon sample rests securely within a sealed tube on the Martian surface, awaiting its fate. It holds what could be the most significant scientific discovery in human history, tangible evidence that could fundamentally alter our understanding of life's place in the cosmos. But while that sample awaits, another development has been unfolding much closer to home, one that compels governments to confront questions they would prefer to avoid. Chapter 3: UFO Mystery deepens. Congress unveils shocking footage. On September 9, 2025, Congressman Eric Burleson of Missouri addressed a House Oversight Committee hearing and presented video footage that had never been publicly disclosed. The recording, dated October 30, 2024, depicts a luminous spherical object moving against a dark backdrop. Subsequently, a Hellfire missile enters the frame. The missile directly strikes the object. What transpires next defies our conventional understanding of missile mechanics. The object does not explode. It does not fracture. It does not even appear to decelerate. The missile seems to rebound, continuing on its own trajectory, while the orb proceeds unimpeded. "That's the Hellfire missile hitting that UFO and just bouncing right off," Burleson remarked, commenting on the video. And it kept going. He paused, then posed the question that has been echoing through defense circles ever since. "I'm not going to speculate what it is, but the question is, Why are we consistently being blocked from this information? The footage was captured by an MQ-9 Reaper drone operating off the coast of Yemen. At the time, the waters near Yemen constituted an active combat zone, with U.S. Navy vessels and aircraft safeguarding commercial shipping lanes against missile and drone attacks launched by Houthi militants. American forces were routinely intercepting threats in that region. However, this object, whatever its nature, did not behave like a conventional drone or missile, and it certainly did not respond to a Hellfire strike in the manner of any known aircraft. When requested to authenticate the video and provide details regarding its origin and timing, the Department of Defense offered no comment. A defense official informed reporters, "We have nothing to provide on this." A Pentagon spokesperson added, "I have nothing for you." This reticence only amplified the enigma. Yet, the Yemen video was not the sole revelation during the hearing. Multiple military veterans testified under oath regarding their own encounters with unidentified anomalous phenomena, the government's current designation for what were formerly referred to as UFOs. Air Force veteran Dylan Boland recounted an incident in 2012 when he stepped outside for a cigarette break during an overnight shift at Langley Air Force Base in Virginia. A triangular craft hovered above him for several minutes, silent and stationary. Then, according to Boland, the object rapidly ascended to commercial jet altitude and departed the area at a high velocity. Boland officially reported the incident. He was interviewed by ARO, the Pentagon's All-Domain Anomaly Resolution Office, in 2023. However, rather than being taken seriously, he claims his report was dismissed. To compound matters, he asserts he faced workplace reprisal, manipulation of his security clearance, and blacklisting from employment with federal intelligence agencies. His testimony painted a picture of a system that not only fails to investigate UAP encounters, but actively penalizes those who come forward. The hearing was not solely about individual sightings. It addressed the issue of transparency, or rather, the lack thereof. Representative Annaplina Luna, who chairs the task force, commenced the session by stating, "For too long, the issue of unidentified anomalous phenomena, commonly known as UAPs, has been shrouded in secrecy, stigma, and in some cases, outright dismissal. This is about national security, government accountability, and the American people's right to the truth. Herein lies what distinguishes this moment from decades of UFO speculation. The witnesses are not fringe conspiracy theorists. They are military personnel with impeccable service records, security clearances, and direct operational experience. The footage is not grainy cell phone video captured from someone's backyard. It is sensor data acquired from advanced military platforms during active operations in contested airspace. And the resistance to disclosure is not emanating from clandestine groups, but from official Pentagon offices tasked with investigating these incidents. ARO has consistently maintained that it possesses no verifiable evidence of extraterrestrial activity or technology. The agency asserts its adherence to a rigorous scientific framework and a data-driven approach to better comprehend UAP. However, critics point out that many of the most compelling cases, including the Yemen incident, are often explained away using logic that does not quite hold up. Consider the infamous Go Fast video from 2015, which showed a rapidly moving object appearing to traverse at high speed above ocean waves off the coast of California. ARO analysts ultimately concluded it was an optical illusion involving a weather balloon, attributing the apparent high speed to parallax and the angle from which the Navy F-18's camera viewed the object. Yet, pilots who witnessed these phenomena firsthand, not merely through sensors, insist that the explanations do not align with their experiences. Some analysts have posited that the Yemen orb might also be a balloon adrift in high-altitude winds and reflecting sunlight. The theory suggests that its rapid movement was an illusion caused by parallax as the drone's camera tracked it. And the missile, perhaps it simply missed, and the angle of the footage created the impression of a direct impact. However, former senior intelligence official Luis Elizondo, who testified at the hearing, strongly refuted that explanation. "We've never seen a Hellfire missile hit a target and bounce off," he stated. "When a Hellfire makes a kinetic strike on something solid, there's usually not much left of whatever it is it's hitting. It's very, very destructive." So, what is our takeaway? Either the U.S. military encountered something possessing technology far beyond our current capabilities, technology capable of withstanding a direct missile strike and continuing to operate, or there exists a mundane explanation that officials are unwilling to share publicly for reasons we can only surmise. Neither scenario is particularly reassuring, and this is not an isolated occurrence. The National UFO Reporting Center logged over 2,000 UAP sightings in the first 6 months of 2025 alone, a significant increase compared to previous years. The Pentagon has documented over 750 new accounts between May of 2023 and June of 2024. Whatever is transpiring in our skies is occurring with greater frequency, and an increasing number of individuals are paying heed. While governing bodies wrestle with inexplicable atmospheric phenomena, a considerably more predictable yet no less momentous event has been unfolding overhead, powered by the celestial body that sustains all life on our planet. Chapter 4: Solar Fury, the Sun's Final Outburst. In October of 2024, scientists issued a declaration that ought to have captured global attention, but was instead lost amidst the daily clamor. The Sun has attained solar maximum, the zenith of its 11-year activity cycle. To most, this sounds like arcane astronomy, a matter for academics, rather than an influence on daily existence. However, the current state of our star is anything but abstract. The most potent effects may yet lie ahead. The crucial aspect of solar maximum that often goes unmentioned is this: the peak of solar activity does not signify an end to dramatic occurrences. Instead, it heralds a period that could, in fact, generate more geomagnetic disturbances and more breathtaking auroral displays than the maximum itself. Consider it akin to a firework that blazes brightest not at its initial spark, but during its concluding, explosive moments before its brilliance fades. Our sun is on the cusp of its final, powerful emission. This emission could illuminate the skies worldwide for the next 2 years. Paley, a solar physicist at the Norwegian Space Agency, articulated this clearly. It's good news for aurora hunters, as peak auroral activity occurs a few years after solar maximum. Thus, we should have several more years with very high aurora activity. Let that resonate for a moment. We are not witnessing the conclusion of the spectacle. We are approaching its grand finale. To comprehend why, we must first understand the fundamental drivers of auroras. During solar maximum, the sun's surface becomes pockmarked with sunspots, areas of intense magnetic turbulence where the star's magnetic field lines become contorted and strained. When these lines rupture and realign, they unleash immense quantities of energy in the form of solar flares and coronal mass ejections. A single coronal mass ejection can propel billions of tons of plasma into space at speeds exceeding 1 million miles per hour. When this plasma collides with Earth's magnetic field, it instigates geomagnetic storms that channel charged particles towards the poles. There, they interact with atmospheric atoms, creating the ethereal, shimmering veils of light we identify as auroras. However, the narrative takes a more intriguing turn. Following solar maximum, the frequency of explosive flares and coronal mass ejections begins to decrease. One might assume this implies fewer auroras, but that assumption would be erroneous. During the waning phase of the solar cycle, a different phenomenon occurs: the formation of long-lived coronal holes. These are dark regions in the sun's atmosphere where magnetic field lines unfurl into space, permitting continuous streams of fast-moving solar wind to escape. These high-speed streams can persist for weeks or even months, bombarding Earth's magnetic field with sustained pressure that triggers geomagnetic storms just as dramatic as those caused by coronal mass ejections. As explained by solar physicist Shah Scoff, during the declining phase, we actually have more geomagnetic storms. Maybe the sun's actual eruption activity slows down a bit after you peek through solar max, but because you still have coronal holes forming, and you still have quite a few eruptions, when you add those together, you get more frequent and sometimes more intense auroral displays. We are already witnessing this unfolding. In early October of 2025, Earth experienced 5 consecutive days of geomagnetic activity, driven by a rapid solar wind stream originating from a coronal hole. Solar wind speeds peaked at 768 kilometers per second before gradually diminishing to 608 kilometers per second. Even at these reduced velocities, the solar wind was sufficiently powerful to trigger isolated G1, or minor, geomagnetic storm levels. Auroras graced the northern latitudes, visible as far south as New York on certain nights. Photographers in Iceland, Norway, Canada, and the northern United States captured breathtaking images of green, pink, and purple lights rippling across the sky. And this was merely a prelude. A minor coronal mass ejection, ejected by an M1.5 class solar flare in early October, is anticipated to reach Earth around October 8th, potentially precipitating another bout of disturbances. Scientists forecast that the current solar cycle, cycle 25, may sustain elevated levels of geomagnetic activity well into 2027 or beyond, fueled by this confluence of lingering eruptions and persistent coronal holes. Yet, another factor comes into play, one unrelated to the sun itself. Earth's orientation during the equinox season, which we are still experiencing in early October, renders our planet more vulnerable to geomagnetic storms. During equinoxes, the angle of Earth's magnetic field relative to the incoming solar wind creates conditions conducive to a greater influx of particles, enabling them to penetrate our defenses and trigger more intense auroral displays. It is akin to opening a portal that is usually partially ajar. The practical ramifications of this solar activity extend beyond mere visual splendor. Geomagnetic storms can disrupt radio communications, interfere with global positioning systems, accelerate satellite orbital decay, and in extreme scenarios, even jeopardize power grids. During the Great Geomagnetic Storm of March 1989, triggered by a potent coronal mass ejection, the entire province of Quebec was plunged into darkness for 9 hours. Transformers overheated, circuit breakers tripped, and millions of individuals were left without power. That storm registered G5, or extreme, levels on the geomagnetic storm scale. The storms we are currently observing have predominantly been in the G1 to G3 range, moderate by comparison, yet still potent enough to create challenges for satellite operators and airline pilots navigating polar routes. Scientists employ a metric known as the KP index to quantify geomagnetic activity on a scale from 0 to 9. A KP value of 5 or higher signifies storm conditions. Throughout the first week of October 2025, the KP index fluctuated between 3 and 5, with transient spikes into storm territory. Forecasters anticipate this pattern will persist, with frequent unsettled to active conditions punctuated by occasional more severe storms in the ensuing months. For those of us not engaged in satellite operations or power grid management, the primary impact of this solar intensity is sheer beauty. Auroras are among Earth's most magnificent natural spectacles, and the next 2 years may offer some of the finest viewing opportunities in decades. Individuals residing at high latitudes, above 50 degrees north or south, will have regular chances to witness the lights. Even those at mid-latitudes, down to approximately 40 degrees, may catch fleeting glimpses during more powerful storms. The sun's final flourish is proving to be a celestial spectacle for the ages. But while the sun paints our skies with fire, other cosmic voyagers are approaching from the depths of space, bearing their own unique brand of wonder. Chapter 5: Comet Chaos. 3 green visitors illuminate October skies. Something extraordinary is occurring in October of 2025. Look skyward on a clear night from the correct vantage point, and you might behold not 1, not 2, but 3 comets visible simultaneously. All possess a verdant hue. All were discovered mere months ago, and one of them may attain a brightness sufficient for naked eye observation. This is a rare boon in an era when most comets remain disappointingly faint. The star of this cosmic display is Comet C2025-A6, more commonly known as Comet Lemon, named after the Mount Lemmon Observatory in Arizona, where it was first detected on January 3, 2025. At the time of its discovery, it registered a magnitude of 21.5, so faint that astronomers initially mistook it for an asteroid. It was only upon subsequent observations, revealing a condensed coma and a short tail, that its true nature became apparent. For much of the year, Comet Lemon remained an obscure celestial body, tracked by professional astronomers, but largely overlooked by the public. Initial predictions suggested it would peak around magnitude 9 near its perihelion in early November, bright enough for backyard telescopes, but far from naked eye visibility. Then, an unexpected development occurred. In mid-August, after emerging from solar conjunction, a period when the comet was obscured by the sun's glare, observers noted it was significantly brighter than anticipated. By August 19th, its magnitude had surged to 11. A short, spiky tail became discernible, and the brightening did not cease. By late September, Comet Lemon had reached a magnitude of 8 to 9, easily observable with binoculars and small telescopes. Astrophotographers began capturing stunning images, depicting not only the luminous nucleus and surrounding coma, but also an extended, active ion tail streaming away from the sun, complete with swirls and knots as it interacted with the solar wind. On September 30th, the comet had brightened to a magnitude of 6.6, with an ion tail spanning approximately 3 degrees across the sky, and a dust tail also becoming apparent. Current projections, updated almost daily with new observational data, indicate that Comet Lemon will achieve a magnitude of 4, possibly even 3, upon its closest approach to Earth on October 21st, at a distance of 56 million miles. This places it on the very threshold of naked eye visibility. From locations with dark skies, far from urban light pollution, individuals might actually be able to discern it as a faint, fuzzy star. And unlike many comets that reach their peak brightness when too close to the sun for safe observation, Comet Lemon will be advantageously positioned in the evening sky, approximately 42 degrees from the sun, visible in the west about an hour after sunset. The comet will continue to brighten post-closest approach as it journeys towards perihelion, its nearest point to the sun, on November 8th. The most favorable viewing conditions are anticipated around Halloween and into early November, when Comet Lemon will traverse the constellation of Fucus. For observers in the Northern Hemisphere, this presents a once-in-a-lifetime opportunity. Comet Lemon follows an exceptionally elongated orbit and may not return for 1,350 years, if at all. But Comet Lemon is not alone. Comet C 2025 R2. Swan was discovered merely weeks prior, precisely 1 day before reaching its closest proximity to the Sun. We did not detect it sooner because the Sun's glare concealed it from ground-based telescopes. It was actually identified by keen-eyed amateur astronomers Vladimir Bezugi and Michael Matiazzo in images captured by the SWAN instrument aboard NASA's Solar and Heliospheric Observatory, a space-based telescope designed for solar studies, hence the name SWAN. This comet will not significantly increase in brightness as it is now receding from the Sun, but it will become easier to observe as it gains distance from the Sun's glare from our perspective. On October 20th, it will achieve its closest approach to Earth at a distance of 24 million miles. Spectacular photographs have already captured its tail extending beyond the star Spica. This weekend, it will pass within 1 degree of Mars, creating a remarkable photographic opportunity for astrophotographers who can frame both celestial bodies together. The third member of this celestial trio is Comet C 2025 K18 Atlas, named after the Asteroid Terrestrial Impact Last Alert System, a survey designed to identify near-Earth asteroids, but also adept at spotting comets. Comet Atlas is fainter than the other two, but is steadily brightening as it approaches the Sun. It will be most visible before dawn in the coming weeks for patient observers equipped with binoculars or small telescopes. The common characteristic of all three comets, being green stems from diatomic carbon molecules composed of two bonded carbon atoms, which absorb sunlight and re-emit it at a wavelength perceived as green by the human eye. As comets draw nearer to the Sun, solar radiation disassembles larger organic molecules within their icy cores, releasing diatomic carbon into the coma. The closer they approach, the more carbon is released, and the more intensely they glow green. Intriguingly, a fourth green comet is currently observable, though significantly more challenging to detect. The interstellar visitor Comet 3 Atlas, only the third comet ever identified originating from beyond our solar system, has recently shed its crimson coloration and transformed into an emerald hue as it interacts with solar radiation in ways we are still endeavoring to comprehend. However, that is a narrative we shall revisit shortly. Comet Lemon has already surpassed all initial expectations, and there is genuine enthusiasm among astronomers regarding its potential peak brightness. Nick James, director of the Comet section of the British Astronomical Association, informed spaceweather.com, "This comet is developing very nicely, and it is already an impressive object, well placed for observation in the morning sky. It is definitely worth getting up for." The inherent unpredictability is a key element contributing to the captivating nature of comets. Unlike planets or stars, which follow predictable trajectories and maintain consistent luminosity, comets are wild, erratic entities, sometimes disappointing, occasionally spectacular. They can brighten abruptly in sudden outbursts, fragment without warning, or inexplicably fade into obscurity, precisely when they were anticipated to deliver a magnificent display. Predicting a comet's behavior is akin to forecasting the weather 6 months in advance. While educated conjectures can be made based on physical principles and historical patterns, nature always retains the prerogative to surprise. And it is precisely surprises that October of 2025 is delivering. 3 green comets racing across our skies concurrently, one potentially visible to the naked eye, the sun ablaze with activity, auroras dancing at mid-latitudes, asteroids stealthily bypassing our defenses, and on Mars, a rock adorned with markings that might represent fossilized remnants of ancient life. Yet, as all this cosmic drama unfolds naturally, a single company is poised to launch the most potent rocket ever engineered, a machine that could either revolutionize space travel or become another forgotten entry in the annals of ambitious endeavors that fell short. Chapter 6: Starship's Final Act, SpaceX's Moment of Truth. Mark October 13th, 2025. If all proceeds according to plan, and with SpaceX, that remains a perpetual uncertainty, the world will bear witness to the 11th test flight of Starship, the tallest and most powerful rocket ever constructed. However, this is no ordinary launch. Flight 11 will mark the final flight of Starship version 2. All subsequent iterations will be larger, more potent, and theoretically more dependable. The critical question is whether version 2 can conclude its operational life on a triumphant note, or if it will contribute another fiery explosion to a year already replete with far too many. Let us address the conspicuous issue at hand. 2025 has not been a favorable year for Starship. The year commenced with a pair of consecutive catastrophic failures that eroded confidence in the entire project. Flight 7 in January saw the upper stage, designated ship, suffer a complete structural failure during its initial engine burn. 4 of its 6 engines prematurely shut down, resulting in a loss of attitude control and a total loss of telemetry. The vehicle's disintegration was observable from Florida, Jamaica, and the Turks and Caicos Islands. Flight 8 in March initially appeared successful. The Super Heavy booster was ingeniously captured by the launch tower's mechanical arms, a remarkable feat. However, Ship 34 experienced 4 engine shutdowns during its burn, lost control, and disintegrated 9.5 minutes after liftoff. Then came Flight 9 in May, which utilized the program's inaugural repurposed Super Heavy booster, another significant milestone. But once more, the upper stage failed to accomplish its mission objectives. 3 consecutive failures, 3 ships lost, 3 investigations, 3 rounds of redesigns, and assurances that the subsequent attempt would prove different. Flight 10 in August finally broke the cycle of setbacks. Every component functioned as intended. The booster executed a controlled splashdown as planned. The ship completed its suborbital trajectory, re-entered the atmosphere with its heat shield intact, and executed a controlled water landing in the Indian Ocean. It even managed to deploy Starlink satellites during the flight, a crucial demonstration of capability. For the first time in months, SpaceX and its proponents could collectively breathe a sigh of relief. Now, attention turns to Flight 11, scheduled for 6:15 p.m. Central Time on October 13th, launching from Starbase in South Texas. The mission profile bears a resemblance to Flight 10, but with several key distinctions that render it more ambitious and potentially more perilous. The booster being utilized, designated B-15, previously flew on Flight 8 back in March. It was successfully retrieved by the tower during that mission, confirming its flight-proven status. This time, it is equipped with 24 flight-proven Raptor engines, meaning both the booster and the majority of its engines have already endured the rigors of launch and landing. However, here lies a significant alteration. Instead of attempting another tower retrieval, B-15 will execute a novel landing burn engine configuration that SpaceX intends to implement on the next-generation Super Heavy version 3. The booster will ignite 13 engines at the commencement of its landing burn, then transition to a revised configuration employing 5 engines during what is termed the divert phase. Previously, this phase utilized only 3 engines. The new 5-engine approach introduces redundancy in the event of unanticipated engine shutdowns, a recurring issue that has plagued numerous flights. Finally, the booster will revert to its 3 central engines for the conclusion of the landing burn, entering a state of full hover above the Gulf of Mexico before shutting down and descending into the water. SpaceX is characterizing this as a stress test. They aim to assess real-world vehicle dynamics as the engines shut down and reignite across the various stages of the burn. If successful, this validates the methodology for version 3. If it falters, at least the failure will occur over water rather than in proximity to the launch site. The upper stage, Ship 38, carries its own ambitious agenda. It will deploy 8 Starlink simulators, mock-ups of comparable size and mass, to the next-generation Starlink satellites that SpaceX plans to launch commercially. These simulators will not function as operational satellites. They are on the same suborbital trajectory as Starship and will burn up upon re-entry. However, their deployment serves to test the mechanisms and procedures requisite for actual missions. Ship 38 will also attempt to reignite one of its Raptor engines while in space, thereby demonstrating the capacity for maneuvers beyond simple coasting. This capability is fundamental for future missions to the Moon, Mars, or any other destination requiring precise orbital adjustments. Following this, the heat shield will undergo testing, and this is where the situation deliberately escalates in risk. Engineers have deliberately removed tiles from several sections of Ship 38 to intentionally stress test vulnerable areas across the vehicle. Some of the missing tiles are located in regions lacking a supplementary ablative layer beneath. Should the plasma generated by re-entry breach these gaps, it could compromise the structural integrity and result in catastrophic failure. However, SpaceX needs to precisely identify the weak points and ascertain the extent of punishment the ship can withstand before failure. The only viable method to acquire this knowledge is to push its limits until a breakdown occurs. Assuming Ship 38 successfully navigates re-entry, it will execute a dynamic banking maneuver during its final descent, testing subsonic guidance algorithms essential for future flights returning to the launch site. Subsequently, a landing burn and splashdown in the Indian Ocean are planned, ideally without incident. All these preparations are geared towards version 3, the iteration of Starship that SpaceX believes will finally render the system operational. Version 3. Ships will be larger, boasting increased propellant capacity and a greater payload volume. The boosters will incorporate more engines and generate even higher thrust. Most crucially, the design integrates the lessons learned from 10 preceding test flights and countless failures, explosions, and near misses. However, none of that will matter if Flight 11 takes an unfavorable turn. Should Ship 38 disintegrate during the heat shield stress test, critics will undoubtedly cite it as definitive proof of Starship's fundamental flaws. If the booster's novel landing burn configuration proves unsuccessful, it will raise serious questions about the viability of the entire approach. Should a public failure occur, it could jeopardize SpaceX's standing with NASA, which is relying on Starship for the crucial task of transporting astronauts to the lunar surface during the Artemis 3 mission in 2027. The significance of this endeavor cannot be overstated. Starship represents more than just a launch vehicle. It is the cornerstone of SpaceX's overarching strategy for the future of space travel. Its purpose is to drastically reduce the cost and regularize access to Earth's orbit. Furthermore, it is intended to facilitate the establishment of human settlements on Mars, revolutionize the deployment of satellites, achieve in-orbit refueling, and ultimately enable voyages beyond our planet. venturing into realms currently confined to speculative fiction. However, before any of these ambitious goals can be realized, the rocket must overcome its persistent tendency to explode. Flight 11 presents SpaceX with a pivotal opportunity to demonstrate that its second iteration can conclude its testing phase on a successful trajectory, thereby building momentum towards the anticipated third version. The designated period for launch commences on October 13th. Millions will be observing this event, and in the hushed anticipation preceding ignition, a singular thought will resonate universally. Please don't blow up. While SpaceX dedicates its efforts to perfecting its colossal rocket, another nation is actively engaged in a mission that has already traversed billions of miles from Earth, directing its course toward a celestial body that may hold clues to our own moon's tumultuous past. Chapter 7. China's Lunar Enigma, the ambitious endeavor of Tianwen-2. On May 28, 2025, at 1:31 a.m. local time in China, a Long March 3B rocket ascended into the night sky from the Xi'an Satellite Launch Center in Sichuan Province. This event garnered little attention from the majority of the world, yet the payload it carried into space holds the potential to unravel one of the most perplexing mysteries in our cosmic vicinity. Could a fragment of the moon be adrift in Earth's orbit, masquerading as an asteroid? The spacecraft, designated Tianwen-2, is the second undertaking in China's planetary exploration initiative. Tianwen-1 successfully reached Mars, deploying both an orbiter and a rover that remain operational to this day. Tianwen-3 is slated to attempt the return of samples from Mars, potentially preempting NASA's beleaguered Mars Sample Return Program. Tianwen-4 is planned to visit both Jupiter and Uranus in a single mission. However, Tianwen-2 is focused on a target far closer and significantly more enigmatic, an object known as Kamo-O'Alewa, also identified as asteroid 2016 HO3. Kamo-O'Alewa is what astronomers classify as a quasi-satellite, a near-Earth object that appears to orbit our planet, despite its primary orbit being around the Sun. Its orbital path is so synchronized with Earth's that from our vantage point, it seems to be perpetually dancing around us, never venturing too far and never being pulled away. This asteroid measures between 40 and 100 meters in diameter, roughly equivalent to the size of a Ferris wheel. It completes a solar orbit every 365 days, aligning almost perfectly with Earth's annual cycle. This peculiar orbital ballet has been ongoing for at least a century, possibly much longer. What truly sets Kamo-O'Alewa apart is its spectral signature, the manner in which it reflects sunlight, which bears a striking resemblance to weathered lunar rocks. In 2021, astronomer Ben Sharpless spearheaded a study suggesting that this asteroid might, in fact, be a substantial chunk of rock ejected from the moon by an ancient impact. The name Kamo-O'Alewa itself originates from a Hawaiian creation chant, alluding to an offspring that journeys independently, a poetic metaphor for a lunar fragment wandering through space while maintaining proximity to its parent body. If this hypothesis holds true, Kamo-O'Alewa could provide invaluable insights into the moon's bombardment history, shedding light on the magnitude and force of impacts that have sculpted its surface and potentially yielding pristine lunar material uncontaminated by Earth's environment. Nevertheless, an alternative explanation exists. Kamo-O'Alewa could indeed be a main belt asteroid that, through gravitational interactions not yet fully comprehended, has migrated into a quasi-orbit around Earth. Such a discovery would be equally profound, revealing migratory pathways within the solar system that current models fail to predict. The only definitive method to ascertain the truth is to venture there and retrieve samples. This is precisely the objective of the Tianwen-2 mission. On June 6th, slightly over a week after its launch, the China National Space Administration disseminated the mission's inaugural update. The spacecraft was functioning as expected and had traveled over 3 million kilometers from Earth. An accompanying image depicted one of Tianwen-2's solar arrays, as captured by an engineering camera, suspended against the void of space. The photograph, though simple and seemingly ordinary, served as confirmation that the spacecraft was operational and healthy. Tianwen-2 is currently undertaking a year-long voyage to Kamo-O'alewa. Upon its arrival in 2026, it will dedicate an additional year to orbiting this diminutive asteroid, conducting close-range observations, mapping its topography, and assessing its mass and composition. This undertaking presents formidable challenges. Kamo-O'alewa is the smallest asteroid ever designated as a target for a space mission. Furthermore, it rotates once every 28 minutes, making it the most rapidly spinning body ever visited by a spacecraft. The act of landing on an object of such diminutive size and rapid rotation is akin to attempting to grasp a carousel in motion while blindfolded. China intends to employ 3 distinct sampling methodologies. The first involves a hovering approach, wherein the lander synchronizes its rotation with that of the asteroid while collecting material. The second is a touch-and-go maneuver, reminiscent of the successful techniques employed by NASA's OSIRIS-REx and Japan's Hayabusa 2 missions, where the spacecraft briefly makes contact with the surface, secures a sample, and immediately ascends. The third, and most ambitious strategy, entails the use of drills integrated into the lander's legs to anchor the spacecraft to the asteroid's surface, enabling a more controlled and extended sampling period. The objective is to acquire a minimum of 100 grams of material, a quantity slightly exceeding 3 ounces. While this may not seem substantial, when sampling an asteroid 50 million miles from Earth with a robotic spacecraft operating autonomously due to communication latency, every gram assumes paramount importance. Once the samples are secured, Tianwen-2 will commence its return journey. In 2028, approximately 2.5 years post-launch, it will approach Earth and release a re-entry capsule containing the collected asteroid samples. This capsule must withstand entry speeds of 12.1 kilometers per second, exceeding those experienced by anything returning from the Moon, generating temperatures and pressures that will rigorously test the capabilities of Chinese heat shield technology. However, the mission's ambition does not cease here. Following the release of the sample capsule, Tianwen-2 will not be retired. Instead, it will utilize Earth for a gravitational assist, propelling itself onto a transfer orbit toward a distinct objective: the main belt comet 311P Pan-STARRS. This interplanetary transit will span approximately 7 years. If all proceeds according to plan, Tianwen-2 will reach the comet in the mid-2030s, enter orbit, and conduct remote sensing studies of this peculiar hybrid object, exhibiting characteristics of both asteroids and comets. The entire mission is engineered to span a decade, involving a single spacecraft engaging with 2 vastly different celestial targets: a sample return from a quasi-satellite, followed by a rendezvous with a main belt comet. This is an audacious and complex undertaking that, if successful, will showcase technological proficiencies possessed by only a select few nations. More significantly, it represents a direct challenge to American dominance in space exploration. While NASA grapples with budget constraints, workforce reductions, and political interference, China is methodically executing a well-conceived and adequately funded program of robotic exploration, steadily advancing toward increasingly ambitious objectives. Tianwen-2 was launched on schedule, is operating nominally, and by 2028, it may deliver the inaugural samples from Kamo'olawa to laboratories on Earth. Should these samples corroborate the theory of the asteroid being a lunar fragment, China will have resolved a significant scientific enigma and demonstrated its advanced capabilities in deep space operations. If NASA's Mars Sample Return program continues its languid progress while China successfully retrieves materials from both an asteroid and eventually Mars, the symbolic ramifications will be undeniable. The space race is far from over. It has merely entered a new phase, characterized by a continuously shifting finish line and competitors engaged in vastly different contests. China is pursuing a long-term strategy, systematically building its capabilities, launching missions, gathering data, and proving that sustained, patient investment in space exploration yields substantial rewards. Currently, Tianwen-2 is millions of kilometers away and steadily increasing its distance each day, propelled by sunlight and ion, thrust towards a destination that most individuals have never encountered. However, upon its arrival, when it collects its samples, and when those samples are returned, the world will undoubtedly take notice. At that juncture, another nation will have achieved something that only the United States, Japan, and now China can claim: the successful retrieval of material from beyond the moon. However, while China steadily propels its space program forward with clear objectives and stable financial backing, the American Space Agency, once credited with landing humans on the moon, is confronting an existential crisis that threatens to unravel decades of accomplishments and jeopardize missions already underway. Chapter 8: NASA's Crisis, Shutdowns, Layoffs, and the Battle for Science. At 12:01 a.m. on October 1st, 2025, the United States federal government officially entered a shutdown. Within hours, 15,000 NASA employees received furlough notices and were instructed to leave their posts. Laboratories fell silent, offices were shuttered, and ongoing research came to a standstill. For the vast majority of the agency, all work ceased. However, this did not apply to everyone. A small contingent of NASA's personnel, numbering just over 3,000 individuals, were classified as essential and required to continue their duties. They will not receive their salaries during the shutdown, but will meticulously log their hours, anticipating back pay upon the government's reopening. Their presence is mandated because their work is critical to maintaining the operational status of spacecraft. Mission control operations for the International Space Station proceeded without interruption. Ground controllers continued to monitor life support systems, prepare and validate commands, and respond to any emergencies. Approximately 1,000 commands are transmitted daily from Earth to the ISS to ensure its continued operation and the safety of its crew. Were these controllers furloughed, the lives of the astronauts would be in jeopardy, hence their continued, albeit unpaid, labor while Congress deliberates on budgetary matters. The other significant exemption from the shutdown is the Artemis program, NASA's ambitious initiative to return humans to the moon. Acting Administrator Shannon Duffy articulated the agency's priorities with utmost clarity in a social media post preceding the shutdown. China is not going to the moon with good intentions. The implicit message was evident. Achieving lunar surface access ahead of China was deemed a national security imperative, sufficiently important to exempt thousands of workers and contractors from furlough. This exemption extends to personnel involved with Artemis II, the crewed lunar flyby mission scheduled for as early as February 2026, and Artemis III, the planned lunar landing mission set for mid-2027. It also encompasses contractors at SpaceX and Blue Origin, who are developing lunar landers and associated hardware for the program. These contractors were advised to continue working through the shutdown, documenting their hours without immediate compensation, as any further delay in the Artemis program is deemed unacceptable. However, the full extent of NASA's crisis extends far beyond the immediate implications of the shutdown. The agency's troubles began long before October 1st. Earlier in 2025, directives were issued by the Office of Management and Budget and acting NASA administrators mandating a reduction in the agency's workforce by more than 4,000 employees. From the end of September through January 9, 2026, thousands of long-serving NASA employees are departing through voluntary resignation offers. These are not temporary furloughs. They represent permanent departures. Over 20% of NASA's workforce is being eliminated. This reduction is not merely in numbers. It involves the departure of top-tier talent, including engineers who contributed to Artemis systems, scientists managing planetary missions, and specialists in critical fields such as power systems, propulsion, and life support. One NASA employee at the Johnson Space Center in Houston, speaking anonymously, revealed that the agency has lost at least one of its preeminent experts in power systems, a catastrophic loss for the development of the nuclear reactor essential for generating power on the Moon. This exodus is fueled by budgetary uncertainty and political pressures. The proposed budget for fiscal year 2026 represents the lowest funding level for NASA since 1961, when adjusted for inflation. The very year Alan Shepard became the first American in space. The budget proposal includes a staggering 47% cut to NASA's science programs. If enacted, this would lead to the cancellation of 41 missions, including spacecraft that are already in operation and actively making discoveries. Consider this for a moment. 41 missions canceled, not those still in the planning or development stages. These are missions currently in flight, telescopes observing distant galaxies, probes exploring other planets, and satellites monitoring Earth's climate. The proposal would effectively shut down spacecraft that have been traversing the solar system for decades, resulting in the waste of billions of taxpayer dollars and the irreversible loss of invaluable scientific knowledge. The list of threatened missions reads like a compendium of humanity's greatest achievements in space exploration. The Nancy Grace Roman Space Telescope, a flagship observatory designed to identify hundreds of thousands of exoplanets and survey over 1 billion galaxies, would be canceled despite being nearing completion. OSIRIS-APEX, currently en route to study asteroid Apophis during its close flyby of Earth in 2029, would be deactivated mid-flight. The Mars Sample Return mission, despite having samples already awaiting retrieval on Mars, would be abandoned, potentially allowing China to surpass the United States in returning Martian material to Earth. Even missions that have unequivocally demonstrated their value are not exempt. The Chandra X-ray Observatory, which has been observing the high-energy universe since 1999 and has made discoveries that have fundamentally reshaped astrophysics, is now on the chopping block. The Hubble Space Telescope, arguably the most iconic scientific instrument ever constructed, could face a reduction or elimination of its mission support. The proposed cuts extend beyond space exploration. Earth science missions tasked with monitoring climate change, tracking deforestation, measuring sea level rise, and providing critical data for weather forecasting and disaster response are also targeted. Programs dedicated to planetary defense, designed to identify and track asteroids that pose a threat to Earth, would experience diminished funding. This is particularly ironic, given the recent unexpected flyby of asteroid 2025 TF. Whistleblowers within NASA have publicly stated that imposing a budget that has not been approved by Congress is illegal and violates fundamental constitutional principles. They contend that NASA's legal department should be aware that the administration's actions contravene NASA procedures, regulations, and the will of Congress. Nevertheless, these violations persist, often concealed from public scrutiny. The human cost of these budget reductions extends beyond NASA employees. Universities across the nation depend on NASA grants to fund their research and support graduate students. When grant payments are suspended during shutdowns or budget cuts, entire research programs can falter. Professors find themselves unable to compensate their research teams, and students face the loss of funding midway through their degrees. Decades of accumulated expertise and institutional knowledge can dissipate as individuals are compelled to leave the field entirely. UV astrophysicist Stephen McCandless of Johns Hopkins University, who oversees sounding rocket initiatives associated with NASA, has noted that the disruptions have significantly impacted the availability of funding. He has had to approach his university seeking emergency financial assistance simply to cover the costs of an upcoming launch, and he is considered fortunate due to his employment at a major research institution with the resources to mitigate such setbacks. Smaller programs at less affluent universities lack such safety nets. Meanwhile, international partners are observing these developments with apprehension. NASA's collaborations with the European Space Agency on missions such as Mars Sample Return and the Artemis program involve binding agreements and shared financial commitments. When NASA unilaterally alters plans or cancels missions, it strains relationships that have been cultivated over decades and undermines America's reputation as a dependable partner. Perhaps the most detrimental consequence is the erosion of public trust and the disruption of scientific momentum. Space exploration is an undertaking requiring long-term commitment. Missions necessitate years, even decades, for planning, construction, launch, and execution. A planetary probe cannot simply be paused mid-flight and reactivated later. A mission to Jupiter cannot be postponed by a year and expect the celestial alignment to remain unchanged. The laws of orbital mechanics are indifferent to budgetary cycles or political priorities. When continuity is broken, when programs are repeatedly canceled and restarted, and when talented individuals depart without being replaced, the cumulative damage is profound. Every canceled mission represents a discovery foregone. Every lost expert signifies the disappearance of decades of accumulated experience. Every shutdown necessitates a painful rebuilding of momentum from its very foundations. Yet, hope persists. The space exploration community is actively resisting these developments. Protests have been held outside NASA headquarters in Washington, D.C., with employees and supporters advocating for full funding and an end to the budget cuts. Lawmakers from both political parties, particularly those representing districts with significant NASA facilities, have opposed the administration's proposals. The House and Senate have put forth appropriations legislation that exceeds the president's budget request, though as of early October, no final agreement has been reached. The critical question remains: will this resistance prove sufficient? Will Congress assert its constitutional authority over federal spending and reject budget cuts that would diminish American leadership in space? Will the public demand that their elected officials protect the agency that brought us the moon landings, the Mars rovers, the Hubble and James Webb space telescopes, and decades of discoveries that have expanded human knowledge and inspired generations? At present, NASA stands at a critical juncture. One path leads to continued exploration, scientific advancement, and sustained American leadership in space. The alternative leads to managed decline, canceled missions, a loss of expertise, and a passive role as other nations surge ahead. This choice is not being made by scientists or engineers, but by politicians and bureaucrats, many of whom will not personally experience the repercussions of their decisions. Meanwhile, the individuals who have dedicated their lives to exploring the universe witness their work being dismantled piece by piece. It is October 2025. Asteroids pass undetected. Potential indicators of life remain frozen on Mars. Unidentified aerial phenomena appear in military footage without adequate explanation. The sun is progressing through its final active phase. Comets are hurtling towards us from the darkness. China is executing ambitious missions with clear objectives and stable funding. A private company is constructing the most powerful rocket in history, while a government agency that once placed humans on another world struggles to keep its operations afloat. The universe is indifferent to our budgetary debates and political disputes. It continues its ancient cosmic dance, unconcerned whether we choose to observe, to study, to explore, or to simply turn away and disregard its significance. However, it is significant. Every discovery we make, every question we resolve, every mystery we unravel contributes to the collective sum of human understanding and serves as a reminder that we are part of something immeasurably grander than ourselves. And currently, we are in peril of forgetting this fundamental truth at precisely the moment when we need it most.